First thing what I wanted to do, unless there's something pressing, is hand it over and allow 30 or so minutes for Keysight to talk about the latest happenings during the week. Good. Okay, go ahead, Chris.
Oh, thanks for that intro.
Mm-hmm.
So last week I did a sneak preview of the very first inklings of the Scythrift server framework working, where we actually built everything and connected to the behavioral model with the Scythrift server. And in the last week, I've pretty much sewn up all the framework, and we have the ability to run Ptf or Ptf tests. And I wanted to kind of review that and actually do a bit of a update on the whole behavioral model testing since the beginning of June when we first talked about it. So I'll share my screen. And, feel free to stop and ask questions or raise your hand anytime. It's meant to be interactive.
Okay.
So here are the major updates since June 8th, when I first presented like our aspirational roadmap of how we're going to get to Scythrift testing. And so this is what's actually been done since then. You can pretty much do a build and test with 3 commands, and you don't have to know what's going on under the hood. But I've tried to make it easy for test developers to get under the hood and write test cases as well. So if we just review this list, we already had P4 code compiling, and libsci was already built from the P4 code. It was auto-generated. I did add some enhancements to allow it to actually interact with the Scythrift server. You need certain kind of initialization commands like sci API query and sci get switch attributes, things like that. So I put in some skeletal code, enough to get this past this step. What happens is when the Scythrift server first connects to the device, it has to get, well, to libsci, it has to get the APIs. It has to query what are your APIs for, doing this table access or that table access. That's the sci paradigm. So we had to add enough code in there, but there's still work to be done, and that'll be on the task list, which I'll review later. So we're building the Scythrift server and client using the auto generation framework that Intel submitted to OCP last fall, and pretty much has been in development and in use since then. So we have that integrated, and there was a few issues I needed to file with the side project and PRs to get past a couple of little hurdles, but it was very easy to overcome. And so there's some PRs pending. Right now I'm using a dev branch of Sci. I created a Docker image that has the Scythrift client. And what that means is it has all the Python libraries, tools, infrastructure needed to write and run PyTests or Ptf tests. So I'll review that a little bit on the diagram in a minute. So the frameworks are integrated, all the tools and libraries. And also in this Scythrift client, the entire Sci Ptf framework and all the test cases from the Sci repo are actually buried into that or embedded into that image. So you really have all the resources you need to write tests, both upstream tests that are already there, plus ones that you want to add. And I'll make some comments in a while about how we're going to eventually use the dash branch of Sci and get that merged into here as well. So we even have all the enhancements that Intel talked about in previous meetings, where they're allowing you to run all the Ptf tests on even a 2-port device, and it will screen out tests that don't apply. So it's that dash enhancement that they've been working on. I wrote a few exemplar tests for both Ptf and PyTest so people can see what the structure is like. And what you can do is take that as a starting point and start creating your own tests and elaborate. But the kind of the start and stop, the skeleton is there. Lots of readmes, Docker file streamlining, which we had a PR last week, which we did accept, I think last maybe Wednesday after the meeting. So the Docker files are smaller. And I've tried to make it so you don't actually need to install any libraries on your development environment. Previously, you had to do Python and pip and Snappy and things like that. Now it's all embedded inside the SciThrift client container. So if I did this right, you really don't have to contaminate your host environment, which is ideal. You don't have to install stuff. You don't even need virtual env from Python or anything. It's just all inside the containers. Christina and I have worked with the Microsoft IT team to get an Azure Container Registry created for our use. We're not using it yet, so that's an upcoming task where these Docker files, these images that are living right now in my own Docker hub, we'll move them to Azure and have a proper home for everything. And then there's a few gaps we found, but the workarounds are there and working. And also people sort of behind the scenes, I reached out and got several friendly, brave souls to try out these dev branches. And it's always really a help because you immediately find out things you assumed because it works in your environment and it really doesn't work for someone else smoothly. So there's probably still a few bumps. If you do have to do a workaround or some kind of a fix when you run through this, please let me know. Either file an issue or just email me or some other, even on Teams, because that's the best way to get this stuff solidified. So I'll pause for a minute and then I'll go on to the workflow diagram. But are there any questions up till now? Okay. And then I'll show this in action because this is kind of dry going through bullet lists. Try to make it more fun. So I've shown this variations of this diagram many times and it just keeps getting a little bit more complete. But the big thing is all these containers all work, and the yellow ones are the ones that you use to build stuff by typing make all. And it just builds everything. You don't have to worry about it. And then at runtime, you would run the switch, you'd run the SciThrift server, and then the SciThrift client is what you can run to do tests. And the SciThrift client contains all the goodies you need. I like one button, satisfaction here. So that's what we're trying to get everybody. It's not working for me though. I can't use a slider. Here we go. So this client Docker image is built on the fly in your development environment, and it just takes like 2 seconds. And what it does is it pulls in Python Thrift client library that's built from this whole auto generation framework that I mentioned, pulls in snappy client libraries to be able to run the XCSC traffic generator. It pulls in the entire Ptf framework, and it pulls in all the test cases and that framework from the Sci repo. So it's all copied into this container. So you've got a container that's got everything you need in it to run tests, and you don't have to contaminate your host environment. And you can just type a command and it will run all these tests. I'll elaborate it a little bit going forward where you can tell it which tests you want to run. Right now it just runs them all. So that's just a little bit of an elaboration I'll work on. Now there's two things about this. Oh, go ahead. Question?
Chris, yeah, just a quick. Aren't Scapy and Snappy are two competing things? And do you need both of them, or is it just you mentioned that you have Snappy for the for traffic generation and integration with Ixia and so forth, but what is Scapy here?
Scapy is what's used throughout the Ptf framework. So Ptf packet test framework, which was actually created by Barefoot many years ago, now Intel. It's basically PyUnit test framework plus Scapy plus tons of helper libraries that make it really easy to run the kinds of tests when you're testing data planes. And there's a rich body of tests, like a couple thousand test cases. And the Sonic or the Sci Ptf test repo is completely based on that. And it's great for writing tests that are very straightforward, where you can say, create an Ethernet packet with this contents and that contents, send it into port 1, receive it on port 2, dissect it, compare the contents, test, pass, or fail. That's kind of the paradigm. And so there's a lot of people who know how to use it, and there's a lot of test cases. So we'll continue to use it, and Intel is going to be building on that substantially going forward as well. So that establishes Ptf and the need for Scapy, right? Ongoing support. and it's great for packet at a time test. Snappy has kind of a different role, and it's a client library that can run software or hardware traffic generators, and it's very good at running tests that have flows and scale. So it's very expressive to say, create 1,000 flows with the Ethernet address incrementing like so, and with just a few simple commands. You can't do that in Snappy. So that's one of the differences. Another difference is you can run these same configurations in a software traffic generator, which is XCSE. You'd actually run these same tests on a hardware traffic generator at line rate. So these are kind of complementary paradigms, and they work very well. Both of them are valid. So we're going to support both and not try to dictate. But there will be tests where it doesn't make sense to try to do them as Snappy, like we want to do extreme flow scales, etc. Just be hard or even not feasible to do it in Snappy. Does that help answer the question?
Yeah, definitely. Thank you so much, Chris. I
And
think that actually explains it. Yeah,
and
I think so. You are providing the choice to the I
Right.
guess the test writers to choose whichever they want based on the capabilities. Okay, good.
Yeah, and of course, we're in love with Snappy and XCSE because that's our product, but we're not going to play favorites in the community, and we're going to let it be a meritocracy, right? Whatever tool works for the job, let people use it. And I think over time we'll find out which tool works best in which situation. And I think there's a place for both.
Makes sense.
Yeah.
Makes sense. But the tools will be using one or the other at any given time, or
Well,
the test. Yeah. No?
We'll actually have a mix of test cases, which I'll show you. There's already both in there, and we'll probably be running test suites in each environment using mix and match of different generators.
Okay.
So there's no either or. It's both. And I think we'll find over time some tools will really shine in certain areas and some will shine in others. One thing I want to point out is when you build this container, it has a complete copy of the dash pipeline test directory, which contains all the test cases. But you can also run it in a mode where you mount from your host environment. Well, let me stop a minute. When it copies that in, that means this container has everything in it. You could actually run it on a different device than the behavioral model. This could also be the basis for talking to a hardware device, right? Running on a host. This could run on a host. Your hardware device might be a DPU. So we're building in the way to have a self-contained test client as well. And even the test cases are buried in it. But for development, you don't want to necessarily have a container with all the tests nailed down and copied into it like statically. So you can also mount the test directory on your host in your code development environment into this container under a test dev directory, and you can run tests from either. So you could run tests that are already kind of, I call them production tests, they're already copied into the container, or you could have this container running live and be using tests and changing these tests in real time live and see that file directory on your host and edit in real time and run tests and debug, change a line of code, run it again without even shutting down this container. So we've kind of got a lot of choices here. And as people start developing tests, they'll find the workflow that works best for them. And I've tried to document this. Maybe I did a good job, maybe not, but please give me feedback if it's not clear. So does that make sense about the distinction between running tests that are copied in the container, like at build time, versus running tests that are right in your development environment live? Do people understand how Docker can mount file system from your host into the running container? It's like a symbolic link almost. It can see everything in your host if you want. So that's kind of a mouthful. Let me see what my next slide says. Okay. So this is kind of the quick start. And I've had a few people go through it. I'm always improving it when something is not quite as smooth as I thought it was. But really, you can just install some prerequisites. You need Ubuntu. You need Docker and Docker Compose. you just need Docker Compose to run the XFC tests, not the PTF. But I'll show how to install that. Clone the repo, check out the branch, which is usually going to be main for most people, but people who are brave souls will check out my dev branches and from my repo and my fork and do the same sequence. This one command, initialize psi, and then just a few commands, right? Go into the directory, this make command, this make command, this make command, and it runs everything. And I'll show that right now. I kind of showed this last week, but I'm not going to do the make all right now because it takes time. So let me go back. We're going to assume I already did make clean and make all. So it's, I don't know, 5 or 10 minutes to build everything. And so I'll go back to here and I'm going to run the switch. Okay, that's it. The BMB2 is running, waiting for P4 runtime commands on this port. The SciThrift server is running. Okay, so now this is SciThrift listening on port 9092. And just to go back, it's not everyone attends every meeting. We've got this running, and it's looking for P4 runtime commands to program the P4 tables. We've got this running, which is going to translate thrift commands into P4 runtime. So that was, and just to give credit where credit's due, this whole framework here is NVIDIA's contribution. This whole framework here, oh, and so is this, right? Plus the P4 code itself has done a lot. Intel did this whole AutoGen SciThrift framework, and I'm just kind of like a plumber, general contractor, hooking these nice things together, doing a little remodeling. So it's really a work of many.
A Chris, question for you.
Yeah.
So that explains how it would run on BMB2, but if you need to run it on a real hardware that doesn't take the P4 runtime, so
on a real hardware that's not P4 runtime, for example,
right.
like it's side. So what you would have, so here's what would happen. You would, if this was, let's say you replaced, let me zoom in a bit, see how good I do on that. Real hardware, you would have at this line here, this would be, all this stuff would be your real hardware. Okay? You wouldn't have a soft switch. You wouldn't have this adapter, right? You'd have libsci talking to your own SDK. So replace everything to the right of this cursor here with your stuff. You'd have libsci. You'd be able to then compile it against the SciThrift server yourself. And this would be running on your hardware. So everything, this would be all of the vendor stuff. And this would be, the SciThrift client would still work the same client because it's using the same commands. It doesn't know if this is hardware or software. And then you'd have a real traffic generator.
Okay, so I can have my own SciThrift server. It doesn't need to be this container. Right? Then
Yeah,
hook that
exactly.
up with my lab.
Exactly. And one thing I'd like to do is try to make tweaks and adjustments to this to make it even easier for third parties to compile against their tools. So I want to work on one of the next steps I want to do, and I can work, we can work behind the scenes, right? It doesn't have to be in the community. We can collaborate to integrate this framework with your own framework. The hope is that you can import the Dash repo into your own development environment and use that as the Git submodule, for example, and tie your own infrastructure into it and integrate them so you can use the pieces out of here that you want and then substitute in your own solutions for other parts. So that's the goal. And
to add just a little bit, Suresh, the SciThrift server is auto-generated with the SciThrift auto-generated framework, and the libsci will be yours, and it will run on the hardware.
Yeah, there's a documented process that already got upstream to Sci that Reshma and her colleagues contributed that talks about doing this. And so this container is built using the instructions that were in that document. And with modifications to suit the Dash project. what Intel and I hope to do is talk about contributing a Docker container, Docker file and maybe help in documentation on doing this in the Psi repo so that it's easier for people. Because right now it's kind of a recipe where you copy this file, do this command, etc. What we'll do is we'll try to make that even easier, where you just say, here's my library location, make, and it just builds it all for you. So I'd be happy to work with people, also behind the scenes to try to take some of this know-how and incorporate it into your workflow. But we'll try to make some of these components even more general purpose for people. So thanks for the question. So this is this make. I think I was showing. I'm running the switch, the Cythrift server, and then if you want to run all the tests, I haven't built a container yet. So actually, let's just pretend I need to remake this Cythrift client container. Yeah, doesn't take very long. Okay, that's it. I've just created. Oops. Let's see. Let's go back to this diagram. I've just created this container here. And the reason it was so fast is because everything's already built except copying a few things into the container from your environment. There's a base Docker that's already pre-built. It's built in Python. It's copied all these baseline things. So it's pretty fast to remake that container. So I didn't need to do that, but I did. And I'm going to I'm going to run the tests. And what this is going to do is running PyTests and Ptf tests. It's running both sets of suites because there's going to be complementary there. It's done. There's just a few simple tests that are in the repo as starters, but it's already run them as sent packets through the pipeline. You may recognize this output from the original Hello World HCSC test. It's now part of this test suite. So we've got a bunch of tests in there, and I'll just show you where these tests live. I know this is probably tiny, but under dash pipeline test, there's a libsci directory that has the C++ tests. Remember this initial VNet out test that Marian provided? It's now in here. I moved it around a little bit. And then there's a Cythrift directory with Ptf tests and PyTest in it. So here's some basic Ptf tests. If we look, for example, here, here's some Python code. Now there's a little work to be done, which I've already talked to Intel about, but we need help in implementing a few more callbacks in the libsci for the BMB2 in order to fully support Ptf. And right now, I have to inherit the classes from this thrift interplace data plane. That's kind of a generic Ptf test. In order to take advantage of the whole framework where it queries the device, finds out all the device attributes like VLANs and route entries and ports, we need to implement some more APIs in the libsci directory. And that's under, let's see, under templates. There's these Jinja templates that get expanded into C++ code. So there's a little work to be done. I'll go over the list of open tasks shortly. So I wanted to pause again to find out if there's any questions about this workflow. So the workflow could be, you start the switch, you start the server, then you can run tests. You can add to the test, you can edit the test and rerun them without shutting all this stuff down. So it's fairly interactive. So
can you scroll up a little bit and show us the output?
Yeah,
Good
question.
There we go.
Let me let's see where I started. I started here.
Uh-huh.
Okay, so it's running Ptf tests. And so it's going to go through the PTF directory and run every test suite that's in there. So here's one that's called test drift session. All it's doing is connecting to the port and making sure there's a connection on port 9092. So it's kind of nice to see. You want to kind of work your way up, right? You want to have a baby step. Okay, the thrift session's established. Then here's a VNet test where I create some entries and send packets. And let's see, this is, yeah, I'll show you the code for this. And then here's one where we do a XAC test where we spin up the traffic generator and then test this echo through port, right? And then it's sending 1,000 packets. So this tests continuity to the switch, that the switch is passing packets and that the traffic generator works. You know, there's some reality check here. And then here's another one that, let's see. This is where it's connecting to the switch and getting switch attribute, which is kind of dummied out right now. This is one of the workarounds where we don't actually send attributes back to the test script or to the framework. It's faked out. So we need to work on that and add some code. So it's kind of a quick survey, but it's running various tests, okay, and you know, this kind of code.
So a couple of questions, Chris. One is earlier you showed that that you're going to mount a directory from host, right?
Yeah.
So in which step are we doing that?
Good question. Like teed up. Okay, so this just ran tests that were copied into the container when I said make Docker Scythrift client. Okay, so they're kind of in here permanent. Let's say production. Although it only took 2 seconds to build it, so you can just rebuild it every time you change a test. But let's do this one. I'll show you a couple different examples. First, if you just put dev in front of this, and this is another make target dev tests. What this does, I was playing around with it before the meeting. I hope I didn't break it. Okay, it's running. Now it looks the same, right? But this time, swear in court that it was running tests out of the host directory. And the way I can tell is you'll probably see the, yeah, okay. So if you know Docker commands, what this is saying is run the Docker, we're running this local dash Scythrift client. This is the Docker container that you build. Notice it's got this local repo. I just did that to make it clear that it's built in your local environment. It's not being built or pulled from Docker Hub. I'm using the workspace test dev. That's the file or the directory that it will look like inside the container. And I'm mounting my local directory tests into this directory in the container. The working directory in the container is going to be test dev. So any commands run now, it's running them from within that directory. I know that's kind of a long-winded explanation, but I'm going to show something a little more convincing.
So you're expecting, people to have the directory in the same name, so it's like hard-coded name, right? Is it?
It's called test dev. So let me show you something that might be interesting here. So I'm going to, here's another command. Run Scythrift client bash. What that does is it runs the Scythrift client and just gives you a bash session. So now you're in the client as if it were just, Ubuntu running for you. You're now running inside this environment. And I'm going to show it's in the test dev directory. Okay, so let's do a ls. Okay, you've got this PTF stuff. That's just generated when you run PTF tests, and it's just output, right? Logs and PCAP. So you can actually go back and look with PCAP. You can look at the PCAP files and look at the packets. So here's this side thrift directory. So if I do ls side thrift, I'll see I've got a PTF directory and a PyTest directory and these scripts that run everything. So that's the development environment. Now, here I'm in my host workspace and we go into test. Okay, so if I do ls there, okay, same content, right? ls here. Now watch, I'm gonna make an empty file. Touch. Okay, I just created an empty file. See, hello. Now I'm in the host workspace. I just created a new file. See that? It appears inside the container. It's mounted. Now, one more thing. I'm going to go to the test directory inside the container and look at it. It doesn't have that hello file. That's the copied contents before when I built that container. So these are the static tests. I like to call them production tests. They're copied in the container into the image at build time. This is like a test directory, a test development directory. You can see the tests live. You can edit them live. I could go in with my VS Code and start writing tests, and they'll appear in real time inside this test dev directory. Does that help a little bit?
Yes. Yes.
And I try to explain in the README briefly, but once someone sits down and goes through this and starts internalizing it, you'll see how handy it is. Because when I was writing my exemplar test, I just kept this bash session open and just kept rerunning that one test over and over. So let me, yeah, I'll show you an example of interactively working on this stuff. So I'm going to go into the side thrift Ptf directory. Okay, so let's look what's in there. There's two directories. There's the thrift directory and the vnet directory, and those contain some test suites. Okay, so let's go into vnet. Well, I'll just do it from here. So I'll show you a command to invoke Ptf test without running it, without doing a make command. This is like getting down to real Ptf developer, where you know the commands. So I'm telling it to run Ptf, telling the test directory is the current one. You need to tell it where the side library, where the client libraries are, and I have it conveniently mounted to this directory inside the container. Tell it your interfaces. See if that works. Okay, so I just ran a test inside this vnet directory, the host. Now let's see if I can do this without choking, because I didn't rehearse this.
Mhm.
Okay, so bear with me. No, that's the flip side I want. Okay, let's see if I do this right. I'm terrible live, but okay, I'm going to alter this test, save it in my local file system. Let's see if this appears. Did it? Am I in the right directory? That wasn't very convincing. Oh, yeah, look. See that?
Yeah.
I just edited the code in my host, saved the file, and reran it from within the container. So I'm live interacting test suite without having to install anything. It's just running inside the container, all nice and simple. So I think as time goes on, we'll find wrinkles and bumps. You know, that's not perfect. I was doing some things just before the meeting that made me realize there's a couple of rough edges. So this is a work in progress. And I'm sure as people start doing, I just saw a chat. I want to see this.
See.
Do we have a prize for the first ones to contribute the first cases?
Yes,
How about it? Sure.
think of something.
So I think I've probably enough for the demo unless anyone has any other questions. You know, there's a lot here to digest, but I think it's a promising start. Let's see, what did I wanted to, let me zoom my screen out. Okay, the CI pipeline, you can see this was just captured last night. These are these workflows, and I'll actually, let me go to the real GitHub. Okay, so this is the pull request with all this stuff sitting up here. The actions pipeline, you can see every time someone does a pull request, Mukesh did some last night, it's running the pipeline every time. So, you know, it's still doing this compile. As soon as we do this pull request, they'll actually be running unit tests against the pipeline, you know, traffic tests. Now, right now, they're kind of dummy and placeholders. So we need to come up with real tests. And, you know, this is just the start, but now we've got a framework. So there's that. And for example, the most interesting one is the CI. Let me find it. I build these Dockers when we do a pull request, but you don't need, it's kind of just to make sure we didn't break anything. You shouldn't have to pay much attention to those. But here's the pipeline for building and testing the serious pipeline. It should say dash pipeline. So I need to make sure that that's correct. So it's doing all this compiles, building libsci, it's creating the server, creating the local client, Scyther client Docker. It's building the C++ test, running the switch, testing just the side library, which was the original test that Marian provided.
Looks like you have a question from Marian too.
Oh,
He's got his
okay.
hand up.
Great. Good. Question?
Yeah, hi Chris. Regarding the CI pipeline, there are pull requests that change behavioral model, and I tried them myself locally, and I saw that site API generation was broken in a way that metadata is no longer properly generated. So where do we stand on that? Did we include metadata compilation already into CI pipeline or not?
Yes.
It's
Yes.
included?
Yes. So I
Okay.
don't know which branch you looked at. It might have been something.
I tried it on Monday. I'm not sure if it was the latest one. Monday or Friday, I don't remember.
Yeah, the metadata, I think, is when I had to start generating, I think it was in this particular revision because I needed it for the site server. So give this a shot. For example, if you can like pull this in, this branch, and then maybe cherry pick those other pull requests in or something. But let me know if it works or not, because we're at this kind of crossover point here where a lot of things are coming together and we have to kind of dance carefully so we don't step on each other's toes. But I think once we get over this next set of various pull requests and get them all resolved, we'll be in good shape. But you know, just let me know if something's broken.
Okay, thanks.
Yeah. So, you know, here's the pipeline. Here's some Ptf tests, right? This is live. I mean, not live, it was last night, but this is the real deal, right? It's running these Ptf tests in the pipeline. It's running PyTests, XCC, you can see. So it's happening. See, I showed that. This was just, I put this in the slide deck. So I'll upload this. So we just have kind of a, you know, a capsule, time capsule. And then we're ready for more test cases. Right? I tried to put some, not everyone's familiar with writing Scythrift server tests. I'll go over the to-dos in a second. But I did try to capture, because I had to learn how to write Scythrift server tests in the last 2 weeks. You know, this is, if I can learn it, anyone can learn.
It's a good thing you have a learning profile. If you do those personality tests, you're the learner type.
Yeah. I get bored easily, so I'll have to learn new stuff.
Yeah.
I have a question, if
Yeah.
I may, expanding on a question from earlier. We have the one IP test.
Hear you. Richa?
Is the MV2 model ready to run a full end-to-end test? And I assume the answer is no, but the question is what's needed extra to make it actually work and run one test end-to-end that actually works on real hardware with all the, I know, routes being up, sending the VXLAN packet, doing the VXLAN, doing the from VPC VNI 1, moving it to another VNI, having the route inside basically the underlay, overlay routing, and everything in place that will make the whole one IP test work. So being able to send one packet end to end, but under a real use case.
I don't have the answer to that. Maybe Marian has the answer. If it turns into a real long discussion, we might want to continue that on the behavioral model meeting, right? Maybe a quick answer now so we can finish up other items here.
Yeah, so you can run VNet routing use case. What we don't have yet, which is not required to do VNet routing, by the way, but it is still important, is stateful ACL. But the routing itself is already available, and you can run real tests with real packets.
Great. Good answer.
So I'll try to give it a try then.
Great. I just wanted to mention there's this README on the SciThrift, and I talk about a lot of the things I showed you, but there's another section here if you're not familiar with this stuff, as I try to show the directory layout and where to find all the resources. And what's really important is you need to know what all the API calls, all the function signatures, all the constants for the SciThrift test. They're in these files, and they'll be in your workspace. And I kind of went through and like retrospective and tried to summarize how I found stuff. And so if I need to do a test like this, how did I find these things? Where did I look? So here's this VNet test, right? But this is all SciThrift commands, but let's say I know Sci or even just the P4, what do I do? So I talk about going through these files and finding stuff with your editor, search on a string like, okay, direction lookup entry. Where do you find it? Where's the function? How do you find under the hood where everything is? So there is some stuff in here for people who are totally new to this. I think I did some of this 5 years ago, so I had to relearn everything. So I just give a little bit of how to, so you don't have to go in here completely blind. So that's that. Any questions? The last thing is there's a lot of to-dos, and I've got my name next to a few, Marian's name next to a few, Intel next to a few, but we need someone to help finish out libsci to get things like switch attributes so that we can actually run Ptf tests properly. And, then we need to write some test cases like for VNet. I would say those are the two main things I want to point out. So Reshma, do we know if you folks, you and your team want to try to do this part so that the Ptf tests can be properly supported? Something you guys want to sign up for, or are we looking for volunteers?
So the API query which is required in this Sci below the Ptf server that runs on the device, under test, we need an API that will give us the information on the attributes, the capabilities supported on the device, like the number of ports, for example.
Right.
That's the part we will definitely be contributing to. It's already there. So yeah,
Well, it needs to be implemented for Dash. It's
Correct.
not part of the framework, right? So someone needs to write new code.
Yeah. As we have the code in the private repo under Dash, we will add it there.
Okay, but we need it in, I guess I'll have to look at that to see, but this needs to be in the Dash repo running on in this libsci. Right? It needs to be written for this.
Yeah, sure. That makes sense. Yeah.
So the next thing is really just to, where was I? I can show you. As Mircea pointed out, we need to implement some real test cases. So anyone ideally can step in, given what I've shown, even without resolving these attributes, because I've got a workaround, right? You can just kind of ignore that for now, and we'll just know, well, we know it has 2 ports. We don't care what number of route entries. We don't have to support all that. Let's just write a test and make some assumptions. Later, we'll make it perfect and metadata and everything. But we just need some real tests. The outlines are there. We can just drop in and start writing test cases. So if anyone wants to start doing that, that would be great.
So either pick up a work item from the list here or email you to ask about one of them and
Sure.
have a good help. Yeah.
Sure. Or just start going in and write your own test cases and just see
Okay.
how you get a feel, right? It's
Right.
yeah, I think it could be kind of fun.
Yeah. No, that's what I just wrote in the chat window. Maybe it'll be fun.
Who knows? Maybe software is fun.
Yeah. Yeah.
Um,
Thanks, Chris. That's a great update for this week.
thanks.
Mm-hmm.
But we'll leave it at that. Maybe we'll talk more about the data plane implementation in the behavioral model meeting, get to nuances. I don't think we want to deep dive into all of that, but I'm glad Marian's sounded pretty positive about what we can do.
Yeah.
Probably have that. Okay, side thrift demo is done. Too early for beer. It's too early for beer, but I'm going to think about beer.
That's great. I'll mark it done in my list as well.
Great.
And I'm going to put in the chat window here a list of the PRs that we just have overall in case anyone wants to go update theirs. But no, that's great, Chris. That's awesome. I think, we've been 50 minutes and we could probably give back 10 minutes of time unless anyone else has a burning question. And let's see here.
So my request.
I don't have a burning question, Christina, but I do think that this is the kind of stuff that now that it's getting to the point, maybe not this particular week, but soon, we should have a workshop so that people can come in, they can try out what Chris is doing, get help if they need, but by the time the workshop's completed, they're able to do this. And they've written a couple of very simple tests so that we get people, actively hands-on with what's going on here, and so that people can actively contribute as opposed to being too shy to ask questions, and then, really never get to the point where they're contributing tests. And so that's what workshops, are good at. And
that's a good idea.
A 4-hour, day-long workshop for people who are interested in getting that hands-on and getting their questions answered and actually doing, very simple tests. But, going through the exercise, and they go back and they go, oh, I now can build a test case and contribute it back. So
that's a good
idea. Right.
Maybe we let this bake for a couple of weeks and get some feedback to smooth out the big rough edges. And
yeah, I think that's a great idea, Gerald, and I'd be happy to host that or co-host that with Chris. And people in the call now, if you want to put your hand up, if you'd be interested in us doing something like that, just let us put your hand up there. Oh, okay, great. Thanks. Awesome.
Yeah, it can be fun.
Okay, well, I'm going to close the recording now. I'm going to stop it and